and welcome to Cherry Pie Math. This video is going to introduce the idea of square roots. Before we get started, you do need to kind of know what an irrational number is. Actually, that one's not like as important in this case. It's just kind of useful to know what an irrational number is because it'll tie in with square roots later, but you don't have to know it for this video, I guess. But you do really need to know what it means to square something. So if I say to square 4, know that it means 4 times 4, right? Okay, so to do this, we need to understand inverses. So if you pick any number, I'm going to pick 13 because I can. I'm going to add 5 to that number. I get 18. And now I'm going to subtract 5 from the number I just got in the second step. And now I have 13 again. And this will work with whatever number you pick. Why do you think that is? So I want you to pause the video and think about why does this one match the last number even though we had a different number in the middle? So you probably were like, oh, we added, but then we subtracted the same amount. If we had added a different amount than we subtracted, it wouldn't have matched. But because it was the same amount on both sides, they ended up canceling out. And that brings us to what is called an inverse. So in math, every operation has what's called an inverse operation. And that is just like a fancy word for opposite. Kind of. It's more like it undoes something. So I guess like we think about addition and subtraction as opposites, but really they undo each other, and that's why they're inverses. So addition and subtraction are a really common example of inverse operations. You'll also see like multiplication, division. Those are inverse operations. And as you get further in mathematics, you'll be introducing to more kinds of inverses. And today we're learning about another one, the squares and square roots. So to square something, it means to multiply something by itself. So if I was to square 3, it would mean I would do 3 times 3, not 3 times 2. Be very careful about this. I've seen this a lot. We remember it's twice, but then we just remember that when you're squaring it, it means that you're doing it by itself. The reason we call it squaring is because when you find the area of a square, you multiply this is a terrible square, but you multiply the side by the side, and that's where you get the area. So to square something means to multiply something by itself. So we need an inverse to that. Since we were able to square something, we need to be able to undo it. If to square something means to multiply it by itself twice, then to square root means to find what would have multiplied by itself. Which sounds really weird when I say it out loud. What would have multiplied by itself to get the number? So I'll do some examples so you can kind of see what I mean. So for example, let's say I'm doing the square root of 100, right? I'm going to look at that 100 and think what number multiplied by itself would make 100. I know that 10 times 10 is 100, so the square root of that would be 10. So this is the radical, or the square, and this is the square root. So if I was to do it again, I could do it like the square root of 81 would be 9, because 9 times 9 is 81. The square root of 64 is 8. The square root of 49 is 7. The square root of 36 is 6, and so on and so forth. Where you're kind of seeing, these are all examples of perfect squares, meaning that there are no decimals involved. It's just very, very pretty numbers. I take all these integers and I square them and I get the number that's underneath. Notice that the square root of 1 is just 1 because 1 multiplied by itself is still just 1. So that's what a square root is. It's basically looking at this number and thinking what number multiplied by itself would give me the number inside. That would be my square root. So we can perform operations on these square roots, but there's some conditions because not everything is a perfect square, and so we can't always get like a nice number out of it. Sometimes we are going to get an irrational number as a square root. So let's take a look and see what those conditions are. If I have addition and subtraction, they have to have the same inside. We call that the radicand, or we can just call it the inside. We'll just call it the inside for now. They have to have the same inside for me to be able to combine them. And then to do it, we just use the coefficients, which are a lot of words that you may or may not know. Just for reference in the rest of this video, when I'm doing the examples, like let's say we have the 4 square root of 7. This would be called my coefficient. And this whole thing is called a term. And my job is to be combining like terms. And I'll show you what I mean here. So first, we have to make sure that the insides are the same. They are, and they're both square roots. If one of them was a cube root, you wouldn't be able to do this, or any other kind of root. They're both square roots. They both have the same inside, which means I'm going to be able to combine them. To combine them, I look at the number at the front. This one obviously has a 5 in front of it, but this one doesn't look like it has anything, but there is an invisible 1 there. So I just put a 1 there. Now I can do 1 plus 5, because that's a plus. 1 plus 5 is 6, and then this has to stay the same. So that's why when you add and subtract, the inside has to stay the same, because when you combine those, you can't change the inside. So this would be my simplified version, where I have 6 square root of 3. 3 actually doesn't have a square root. That's rational. It's not a nice number. So we're just going to leave it like that. So let's look at another example. We have, again, the same inside. So we know that there's going to be the square root of 7 at the end. What I really have to do now is look at the front and see what those numbers are. I have a 4 and I have a 2 as my coefficients. And I'm subtracting. So it'll be 4 minus 2, which is 2. And that would be my answer there. In this next one, the first 2 match, but the third one doesn't. That means I can only combine the first 2, and I'm just going to have to leave the last one as it is. So 9 plus 2 is 11, and then I keep the square root of 13 the same. And I can't combine it with the 8 square root of 5 because it doesn't match, so I just leave it as it is. And this last one, at first glance, they don't match, right? The 25 and the 100 are not they obviously are not the same number. But if I go back here, I actually would recommend you to at least memorize these 5 because it'll serve you well. Honestly, this whole chart, you'll see it a lot. 7th and 8th grade math is some of the most common things that you'll see on the ACT because it's math that everybody has really been exposed to. And this is a common one because they expect you to be able to know these off the top of your head. So if you get a chance, I would pause the video, write all of these down and make sure that you can remember them and be able to recall them easily. Because now I'm looking at this and I'm like, oh, initially I can't combine them, but wait, the square root of 25 is just 5 and the square root of 100 is just 10, and I totally can do 5 plus 10. That's just 15. And so I was able to combine them. I was able to make them into like terms because I could recognize that I could simplify it. The other ones I couldn't simplify. There was no square root that came out of it really, so I had to leave it as it is, but this last one I could simplify. Multiplication and division are a little bit easier, a little bit harder. I don't know, it's just different. So you actually don't have to have the same inside, but you do have to have the same, what we call index, meaning they both have to be square roots. Both same kind of root, I guess. So these are all of these are going to be square roots. I'm not going to be doing anything with any other kind of index today. But then all you have to do is you multiply outsides, or the coefficients, and you multiply the insides, and then simplify if you can. Simplify if possible. And I say multiply, obviously it could also be division. So addition, subtraction, you're combining like terms, you're making sure everything matches, and then you're combining the coefficients. In multiplication and division, you do outside by outside and inside by inside. So for example, let's say I have, let me change it to white so you can see it better. I have 3 square root of 2 times 5 square root of 7. So I'm going to do 3 times 5 is 15. I keep the square root. I do 2 times 7 is 14. And that's actually it. I'm done. I can't do anything else. I combine the outsides together and I combined the insides together. Let's do the next one. Square root of 20 divided by square root of 5. I'm going to divide them. So I'm actually going to put them together like this. This is another way you can think about it. Or you can think about it as square root of 20 divided by 5. Totally up to you. Either way, you end up with the square root of 4. But wait, we know that the square root of 4 is just 2. So I can put a 2 and I'm done there. I was able to recognize it because I memorized that list of perfect squares. So seriously, if you get the chance, please memorize that list of perfect squares. You're going to see that for the rest of your life, really. But not all numbers are perfect squares, meaning that their square roots are integers. If they are not perfect squares, then the square roots become irrational. So for example, like the square root of 121, that is an example of a perfect square because 11 times 11 is 121. That's a perfect square. 121 is a perfect square. But if I do the square root of 122, that is no longer a perfect square. So my answer would be an irrational number. So some things to remember, square roots and squaring are inverse operations. So if I do the square root of 3 and then I square it, I actually just end up with 3. It's like these cancel out there. Or vice versa. If I have 3 squared and then I square root it, again, these cancel out. You end up with 3. Just the same as if you had plus or minus or multiply or divide. They end up canceling each other out. We can combine square roots with basic operations as long as we meet the conditions. So in addition and subtraction, they have to have the same inside. In a multiplication division, they just have to have the same index. And then most square roots will result in irrational numbers. Square root of 2 is a special one because it's the first integer. It's the first one where there isn't a nice square root. Like square root of 0 is really just 0. Square root of 1 is 1, and then square root of 2, irrational number. There's no fraction, there's no rational number that will multiply by itself to get to 2. So this is the first irrational number that we really come across. Anyway, I hope that helps introduce square roots. Again, like I said before, please, please, please memorize this list. Not only will it help you just do math faster, but it will also help you understand more about what a square root is and how it works, because you can obviously see that anything on the right multiplied by itself would give you the numbers on the left. But yeah, I hope that helps and good luck.